So the first example, we've got x plus 3y is equal to 7. So what are the variables here? The variables are the unknown x and the unknown y. And since there's only two variables, we don't have to use x for every single variable and index them 1 through 2, right? Because if it's only two variables, it's easier just to use a different letter for each variable. So we use x for one of the variables, and we use y for the other variable. Now, according to this formula or recipe for a linear equation, this definition, we should have a coefficient assigned to each variable. So you can see right away, let me zoom in actually so it's a little easier to see. You can see right away that the coefficient on the y, well, that's 3, right? There's a 3 multiplied onto the y. What about the coefficient of x? There's nothing, there seems to be nothing written there. Well, if there's no coefficient written, then it's automatically taken to be 1. Right? There's an invisible 1 being multiplied onto any number. And then the constant term, well, the constant term is equal to 7. That's the constant that's over by itself on the right-hand side. Okay, another example of a linear equation. Here we have 1/2 x minus y plus 3z is equal to the square root of 2. That's an example of a linear equation in the variables x, y, and z. So what are the coefficients? Well, the coefficient of x is 1/2, and I'm going to jump over to the z now. The coefficient of z is equal to 3 because there's a 3 multiplied onto the z. Now what about the y? First of all, there's nothing written immediately in front of the y that multiplies onto it. But second of all, and based on what I said in part A, then that would imply that 1 is the coefficient of y, isn't it? But careful, hang on. You'll also notice that there's a subtraction that happens between the 1/2 x and the y. So that doesn't actually follow the form of a linear equation exactly, but that's okay. It's still a linear equation. That subtraction, the way you interpret that subtraction is you would just say, okay, well that's just built into the coefficient of y. So really, the coefficient of y here is -1. And then finally, the constant term is equal to the square root of 2. Let me back up and actually just rewrite these linear equations in such a way that they follow the form exactly. So that part A, I'm going to write that as 1 times x plus 3 times y is equal to 7. And then for part B, I'm going to write this as 1/2 times x. So the coefficient of x is 1/2. And then the coefficient of y is -1. So I can write 1/2 minus, 1/2 x minus y. I can write that as 1/2 x plus -1 times y. And then lastly, I've got plus 3z is equal to the square root of 2. So that's how I can write it so it fits the form exactly. So it's no problem if we have some subtraction instead of addition. That just means that whatever term comes immediately after the subtraction symbol, that means the coefficient is going to be negative instead of positive. So with that in mind, we can look at our third example here. So our third example, this is a linear equation in the variables x1, x2, x3, and x4. So the coefficient of x1, that's going to be 1. Coefficient of x2 is going to be -2. The coefficient of x3 is going to be -3. And the coefficient of x4, well, hey, that looks like it's the symbol pi, and it is. Okay, so the coefficient of x4 is actually the real number pi. Remember back to the, well, I'll come back to that in a moment. And then our constant term is -1. So every linear equation has a constant term as well by itself. That's not multiplied onto any variable. So back to this pi thing, I just want to remind you that in the definition of a linear equation, all the coefficients and as well as the constant term, they were allowed to be any real number at all. And you know what, maybe we'll just remind ourselves what the real numbers symbol means. So if it's called a blackboard R, so it looks like a capital R, but it's got 2 lines instead of 1 on the left-hand side, and that just stands for the set of all real numbers. Okay, so that includes all the positive whole numbers, all the negative whole numbers. It includes 0, it includes fractions, it includes decimal numbers, whether they terminate or not, whether they repeat or not. It's no problem. It includes all of them, whether the numbers are rational or irrational, like the square root of 2 and pi, like we just saw those appear in linear equations here and here. Oops, saw them appear here and then also here. There's no problem. We're allowed to have any real number at all appear as either a coefficient